This video, we're going to take a look at the 2008 Leaving Cert Chemistry question that came up on Redox. Now, this is a half question. It's about 25 marks. It looks pretty tiny there when you just look at it head on. But if you count up the marks, it is 7 and 6 and 12. And there's a little bit of, I suppose you might underestimate this question because you see the 12 marks at the end is in balancing both of these redox equations. Now, if you're good at those, this is pretty straightforward, easy enough to get these 25 marks. But this is why you need to practice these redox, balance and redox reactions. Because if a redox question comes up, you can be pretty sure they're going to ask you to do that. So do practice them. All right, straight up from the top of the page, we see, okay, so by the way, just setting your timer 10 minutes for this. So go ahead and get your timer to do that now. And straight away, we're jumping into definitions. Every time I've done a redox equation, I've nearly seen this definition, define oxidation. So make sure we're talking about oxidation in two ways in terms of electron transfer and change in oxidation number. So over here at the side here, we're going to do it's B part 1, well, defining oxidation in terms of electron transfer. Right, pause the video, write down the definition now. Okay, so you should know at this stage, oxidation is defined as the loss of electrons. Loss of electrons. Oil rig. Oxidation is loss. And you have to remember that this is for electron transfer. Right, the next thing is to define oxidation in terms of change in oxidation number. So what happens to the oxidation number during oxidation? Pause the video and write down your definition for that. Okay, so oxidation number is, or oxidation, sorry, is an increase in oxidation number. Oxidation number. If you can't remember that, let's go ahead and take an example of lithium. Lithium has one electron in its outer shell. There it is. And lithium is a metal, so it's going to lose that electron. So oxidation is loss. It's losing that electron to become Li+. Okay, assign the oxidation numbers to these. Now, this is an uncombined element, lithium. So what oxidation number would it have underneath? Write it down. 0. And now this is an ion. And we know that a rule for oxidation numbers of ions is equal to the charge on the ion. So this is a +1 ion. So +1. So this is oxidation. What's happening? We're increasing the oxidation number. That's what we said over here. So again, if you're not sure in the exam, check it. Use an example to check. All right, next bit. For the redox reactions below, use oxidation numbers, so be careful what it's asking you to do, to identify the species that oxidized in the first reaction and the oxidizing reagent in the second reaction. Okay, so a couple of things. Let's break it down into two pieces. Let's call it reaction A. I'm going to call it reaction B, just to separate it for ourselves. And in reaction A, we're using oxidation numbers to identify the species oxidized. Okay, cool. So let's go ahead and rewrite out 1, 2, 3. We're going to rewrite out the first equation. So pause the video and do that now. So we started with this ClO minus plus I minus plus H plus react to give Cl minus plus I2 plus H2O. All right, so it said to use oxidation numbers to do this. So the first thing I want you to do is go ahead and assign oxidation numbers to everything in that equation. Pause the video, do that now. All right, so assign oxidation numbers. Again, we should have practiced loads of these in class. I know my class did. In this case, we've got ClO minus. Oxygen is always -2. It's not with a fluorine and it's not in a peroxide, so it's always -2. Up top, that's a total of -2. This is a complex ion, which means that the charges have to add up to the charge on the ion, which is -1. So what can we make chlorine be so that it adds up to -1? Well, +1 minus 2 will give us -1. So in this case, chlorine is +1. This is an ion, so the oxidation number is equal to the charge on the ion, -1. This is also an ion, so +1. This is also an ion. Is that right? Yeah, it is. I'm just double checking that I haven't taken this down wrong. Yeah, it is still -1. This is now iodine, I2, which is an element uncombined. So that's 0. And then water at this stage, quickly we should know, is -2 on oxygen, +1 on the hydrogen. That's one of them you just learn off by heart. Right, just go check my question again to make sure I don't make a mistake. Identify the species oxidized. Okay, so let's find what's been oxidized, what's been reduced. So we're looking on the left-hand side for what changes when it goes to the right-hand side. Well, here I have chlorine going from +1 here to -1 here. So to do that, it had to gain 2 electrons. So gained electrons, 2 electrons, and that is reduction. Okay, that's reduction. And what else is happening here? So in blue, no, I'm going to do it in black actually. Iodine is going from -1 to 0. That means it has lost 1 electron. That is oxidation. So just to clarify, what will we ask? Go check my question again. Look how many times I'm checking the question just to make sure I don't forget what I was asked. Identify the species oxidized. Now, before I went and checked that question, I was sure in my head that I was the species reduced. So again, just well worthwhile always going back to the question. So we're just going to clarify here what has been oxidized. So I minus this thing here has been oxidized. To I2. That's just our clarification to make sure we get the marks. Now, what I'm going to do is I'm going to leave a little space underneath here because I might use this again later on. I know that down below, it's going to ask me later on to balance both equations using oxidation numbers. It helps to have a little bit of space underneath that. So before I go to the next bit, don't forget to go back here and do this next bit. Identify this the oxidizing reagent in the second reaction. So I'm not forgetting to go back to that. So I'm doing that now. So I need to write down the second equation, but I'm going to leave a bit of space underneath. Okay, I'm going to leave a bit of space for my balancing. And I'm writing down my second equation. This is what you should write down. I2 plus S2O3 2 minus react to give I minus plus S4O6 2 minus. Okay. All right. So again, assign oxidation numbers to this. So pause the video and do that now. All right. So show me playing if you've tried to do this. This is an element uncombined I2. So it's oxidation number of 0. Here, oxygen is -2. Total charges on the oxygen is -6. And this is a complex ion. So the total charge must add up to -2, the charge on the ion. So that means that the sulfurs have to have a total charge of +4, and +4 minus 6 gives you -2. That's correct. And there's 2 sulfurs, so each 2. Iodine is an ion, so we'll have the charge on the ion, -1. And now here's oxygen again. It's -2 per oxygen, which is -12 altogether. The total charge must add up to -2 because this is a complex ion. That means that this here is has to be 10 on that sulfur, and that means that each sulfur is 2.5. Okay, so a strange one. We've seen before how you can have decimal numbers in oxidation numbers before, and here is a case of it in an exam question. So let me just check, because it is unusual that we do get that. Let me just check that that is right. -2 -12. Yeah, I just had to check my own maths there just to be sure, because sometimes it can be, sometimes I don't normally expect to see a difficult, unusual one like that in the exam, but it obviously is right. I've double checked. So that is that, and we were asked to identify the oxidizing agent. So to do that, we have to identify which species have been oxidized and reduced. So pause the video and do that now. Okay, so here I see iodine is going from 0 to -1. That means that it has gained electrons, has gained 1 electron, and that is reduction. The other thing that's happening is the sulfur is going from +2 to 2.5. It has gained 0.5 of a minute. No, it has, sorry. What's going on there now? It has lost. That's plus 2.5, lost 0.5 of an electron, like that. Okay, which means that that is oxidation. Right, so just going back to the question and double check again, what did they ask for? They asked for identify the oxidizing reagent in the second reaction. So the oxidizing reagent itself is the thing that gets reduced. So whatever gets reduced, it's the oxidizing agent. So go back here and I'm seeing that it's the I2 that gets reduced. So it must be the oxidizing agent. So I2 is the oxidizing agent. Right, so just take a minute to just double check over what we did there and make sure that you do understand it. Right, so the last bit is definitely the most challenging bit. It says using oxidation numbers or otherwise balance both equations. So using oxidation numbers balance both equations. So we showed you how to do this before. The first thing that we've got to do is balance the electron transfer. Okay, so what I'm going to do is I'm actually going to get rid of the stuff that we've done previously. No, not that much of it, sorry. I better leave that in. Okay. Right, I'm going to get rid of this bit here. And we're just going to clarify what's happening in the electron transfer. So the first thing we're going to write down is that Cl, and that Cl plus 1, has gained 2 electrons to become Cl minus 1. Okay, so 2 electrons. And the second thing that we know, okay, tell me about the other thing. Pause the video and write down what's happened to the other thing that's changed here. Okay, the other thing that's changed is the I minus, this thing here, up here. This thing here has changed as well on the left. So we're going to say I minus, which is -1, has lost 1 electron to become I2. So the first thing that we want to do here is, which is obviously, oxidation number of 0. The first thing we want to do is balance the electron transfer. So what is the ratio here to make sure the electrons are balanced? The ratio here is that we need 2 iodines, 2 I minuses, so that it can transfer electrons to 1 chlorine. So that's our ratio. 2 iodines, because we've got to make 2 electrons, so 2 of these for every 1 of these. Okay, so 2 I's for 1 Cl. That's the ratio of the electron transfer. So to balance the electron transfer, we've got to go back to our original equation, and we've got to balance these out up here on the left-hand side. So what we've got to do is make sure that there are 2 iodines for every 1 of these chlorines. So 2 to 1 is the ratio there. After that, then you just go ahead and you balance the rest of it by inspection. Make sure you've got the same number of each type of atom on both sides of the equation. So checking my right-hand side of my equation, I've got 1 Cl on the left, I've got 1 Cl on the right, so I'm going to leave that the same. I've got 2 iodines on the left, and I've got 2 iodines on the right, just here, I2. So there's already 2 of them. So that's balanced already. I leave it alone. Oxygen, there is 1 oxygen on the left, just here, and there is 1 oxygen on the right, just over here. All good so far. There are 2 hydrogens on the right, just here, and there is only 1 on the left, just here. So to fix that, I'm going to make this a 2, and that's it balanced, guys. Everything is balanced. The electron transfer is balanced. The number of atoms of each type of atom is balanced. So that's that one done. All right. So using that technique, we've got to repeat that for the second reaction. So again, I'm going to rub this out. you obviously shouldn't do that because you've got your final answer there for the previous question. You could possibly write out this whole line again. It's probably the tidiest thing to do. I'm trying to save time here. And what we're going to do is balance the electron transfer. So I'm going to give you a chance to pause the video, try and balance the electron transfer for the second one by yourself first. All right, so the first thing to clarify is to write down what's happening. I2 has, gained 1 electron to become I minus. Okay, so that's what happened, gained 1 electron. The second thing that happened is that S2, or if you like, yeah, S gained, sorry, didn't gain, it lost 0.5 electron to become S4 in the S4O6. So this is S2 in the O3, lost 0.5 electron to become S4 in the S4O6. Quite complicated, I suppose, but again, the big picture here is you've got to make them balance. So make the electrons transfer balance. So if this thing is transferring 0.5 electrons to this thing, then hopefully you'll see that the ratio we need is we need 2 of these so that we can transfer a full electron to 1 of these. Okay, so 2 S2O3s for every 1 I2. That's the ratio. And again, you're looking at the electron transfer. 0.5 to 1 is 2 is to 1. Okay, so 2 is to 1. We need twice. We need 2 things that are given 0.5 electron to satisfy something that's taken 1 electron. Okay, a little bit complicated and convoluted, guys, but that's it's simple enough algebra. I'm hoping that you're following me there. Okay, so again, go to my equation now. I need to make sure then I've got 2 of these for every 1 of these. So up here in my equation, I'm going to do it in, maybe I'm going to do it in a red color just so it stands out. I need 2 of these, that's this thing here, for every 1 of these, that's that thing there. So once you have your electron transfer balanced, then the next thing is to balance everything else to make sure everything else is good. Well, over here, look what we've got. We've got I2. So it's 1 of this whole thing, but that's I2. There's 2 iodine atoms here. And over here, there's only 1 iodine atom. So the first thing I want to do is balance that. Put 2 in front of that. Right, let's check the rest of my atoms. I've got 2 times 2 S's, which is 4. And that's the way it is here. And I've got 2 times 3, which is 6. And that's the way it is there. So what do you know? That's it, balance. So all we have to do is put a 2 in front of the I, and that finished it off. That balanced it for us. Tricky little couple of equations to balance there, lads. But hopefully you followed it along. If you were able to do it by yourself, well done. It's a good job. And that's it, guys. We'll hopefully see a few more of these in the next few questions.